Hello and welcome to our lesson on radical expressions, rationalizing the denominator, a more advanced look. First, let's talk the definition. A rational expression, so no equal sign, combines numbers, variables, and radicals with an operation sign. Could be addition, subtraction, multiplication, or division, but again, there is no equal sign. These would be examples of rational expressions because there is no radical in the denominator position. None there. I could make it into a fraction just by putting a 1 underneath. Same here too. Same here. And for here, even though there's a radical, the square root of a squared is just the regular to the first power. So actually, for here, it's going to be 52 plus m, and that would be the denominator. So that makes that rational as well. How do you rationalize a denominator? First, you're going to multiply the denominator by its conjugate. If you remember, with conjugate, it's the same exact terms, and it's just the sign in between that gets flipped. So if it's x plus 3, the conjugate would be x minus 3. Remember, you must apply the rules of equality to the fraction. So whatever you do to the denominator, you have to do the same exact thing to the numerator. Then you just treat it as a normal multiplication of radicals, and then simplify wherever you can. Let's try an example. If it's not rational, first thing we need to do is the conjugate of the expression. So remember, the conjugate just says copy the same terms but change the sign in between. So we're going to have to multiply 2x to the fourth minus 3x square root of, and then on the bottom you're going to have 6x minus radical 27x to the fourth. Now we need to multiply by the conjugate of the denominator, so that means you're going to have 6x plus radical 27x to the fourth. And then whatever you multiply by the top, you have to multiply by the bottom. Whatever you multiply by the bottom, you have to multiply by the top. So, since we multiplied by 6x plus 24 for the denominator, you have to do it to the numerator as well. Now, once you do that, you're going to go ahead and do a FOIL. And why is it a FOIL? Because you actually have binomials. And when it's binomials being multiplied by other binomials, we're going to have to do FOILing. So let's look at the first one for the FOIL is the numerator. So we're taking 2x to the fourth times 6x. And when we do that, we're going to get 12x to the fifth. Remember, when you multiply, you're really adding exponents. Then you're going to take 2x to the fourth and multiply it by radical 27x to the fourth. And it's a positive because it's positive times positive. So you have 2x to the fourth radical 27x to the fourth. Now you have to continue on, and now you're going to have to do your multiplication of your inward terms. So it's negative radical 3x times 6x. So that's going to get you a negative 6x radical 3x. And then you do your last term. So you're multiplying two radicals together. They're going to stay underneath the radical sign. It's a negative times a positive, so you're going to have a positive. And now you're going to have radical 27 times 3 is going to be 81. And it's x to the fifth because you're adding them. That was all the numerator. Now you have to do the denominator. So we're going to multiply 6x times 6x. And we're going to get 36x squared. Remember, you're adding the exponents. Then it's 6x times radical 27x to the fourth. So you're just going to have a positive because they're both positive. 6x radical 27x to the fourth. Then you're going to do the inside. So now it's negative 27x to the fourth radical times 6x. So that makes it a negative 6x radical 27x to the fourth. And finally, you're going to do your last term, which is radical 27x to the fourth times radical 27x to the fourth. Keep in mind this is a negative times a positive, so you're going to end up with a negative. And you're going to multiply the 27 times the 27, and you're going to get 729x to the 8th because you are adding your exponents. That's a lot. Now, if you'll notice, though, right here, the middle terms on the bottom are exactly the same, except one's a positive and one's a negative. So what happens when you have something that's positive and something that's negative and they're the same? They're going to cancel each other out. That's the whole purpose of doing this, is to get rid of some of the radicals here. So you're going to end up having 12x to the 5th plus 2x to the 4th, and then radical 27x to the 4th. Then you're going to subtract 6x, radical 3x, and then subtract radical 81x to the 5th. Down on the bottom, we have the middle terms cancel out, so you actually end up with 36x squared minus 27x to the 4th. The only other thing you can possibly do, because you have to the 5th, to the 4th, to the first power, and then no x, so none of those are like terms. This is x squared and x to the 4th. The only possible thing you can do is make sure that all your radicals are completely reduced. 27 is not fully reduced, because if we take 27, it's going to be 9 times 3. That's a perfect square, so we can pull it out. So you're going to have 12x to the 5th plus, here's your 2 times your 3 that we took out, so you have 6x, and since we can take a square root of 4, that's going to be 2, plus the original 4 that was there, so you're going to have a 6, radical 3. Then you're going to subtract 6x, radical 3x. Can't do anything with 3 or x, they're fully reduced. 81 though, square root of 81, that's a perfect square. So we're going to take out a 9. And we have 5 here. So how many pairs can we pull out? We can pull out 2 pairs, and we end up with 1 left over. Again, we have to the 5th, to the 6th, to the 1st, to the 2nd. None of them are like terms. It has to stay that way on the numerator. And 36x squared minus 27x to the 4th, they are not like terms, and they have to stay that way as well. So here on step 4, we have found the answer. Be prepared. When you do problems like these, you're going to get long answers like that, and it is perfectly fine. The only thing you have to watch is to make sure that you're carrying over your radicals properly, that you've fully reduced any other radicals that you have, and that you're only combining like terms. Every time that you have something multiplied on the bottom, and you multiply the same radical times the same radical, it's going to cancel out the radicals completely. So you won't have any radicals on the bottom. And that's the point of doing this when you multiply by the conjugate. So let's take a look at another example. First thing you need to do, multiply by the conjugate. So you're going to multiply by 2z minus radical 21y to the 3rd. If you do it to the denominator, you have to do the same thing to the numerator. So we're multiplying by the conjugate of the original denominator. And now with fractions, if you remember, you multiply straight across. However, these aren't fractions, these are binomials, so we're going to have to do foiling. So first outside, inside last. So if we multiply 2z times 2z on the denominator, you're going to get 4z squared. There. And now you're going to multiply the outside. So you're going to get a negative, because it's a negative, times a positive. Negative 2z radical 21 y cubed. And then you're going to take the inside ones. Now it's going to be positive, because this is a positive right here, over here. You've got positive 2z radical 21 y to the 3rd. And you have one more term. You're going to multiply these guys together. If you remember, though, when you multiply the exact same radical by the exact same radical, in essence, all that happens is the radical sign cancels itself out, and you're just left with the radicand and no radical sign. So we don't really have to do all that multiplication. We can just write negative, because the negative times a positive is going to equal a negative, and just the number itself. So you're going to have minus 21 y cubed. That'll be on the bottom. You're going to have to go through the same process for the top. So we have 1/4 y cubed. Instead of writing 1/4 though, let's write 0.25. Let's leave it as a decimal. So it's going to be 0.25 times 2. So you're looking for a fourth of 2. And if you do that, you're going to end up with a half. So we're going to write 0.5 y cubed, and it's multiplied by z. And usually when you have two variables that are different, you write them in alphabetic order. And then you're going to have to do, you did this, now you have to do your last. You're going to have 0.25, and it's going to be a negative, because you have a negative here. Negative 0.25 y cubed, radical 21y cubed. Now we're going to focus on our inside ones. So we're going to do these right here. It's going to be a positive. 2 times 2 is 4, z, and then you just have your radical, y to the 4th. Almost done. We've got our last terms that we're going to multiply together. And this is a positive times a negative, so we're looking at another negative. And 2, and then our radical sign, we are multiplying 21 times 1, which is 21. And then we've got y to the 3rd and multiplying it by a 4th, which really means we're adding. So y to the 7th. It's a lot, but we're almost done. Take a look here. Remember what happens to your middle terms? They're exactly the same and they cancel out. Gone. So we don't even have to worry about them. So let's look. When we take it then, we're going to end up with 0.5 y cubed z minus 0.25 radical 0.25 y cubed radical 21y cubed, and then you're going to add the 4z radical y to the 4th, and then you still have to subtract your 21, your 2 radical 21 y cubed. That was all the top. And there are no like terms here because you have a yz right here. You have just a y cubed. You have z by itself, and then you don't have any variable at all. None of these are like terms, so you just have to leave them written like that. On the bottom, we ended up with 4z squared, and then we had minus 21y to the 6th. Actually, to the 3rd. If you notice 21y to the 3rd, 21y to the 3rd. It went from 2z to 4z squared. So there's your shortcut. Once you multiply by a conjugate, you just square the first one. 2z times 2z is 4z squared, and then remove the radical sign for the second term. So all the work really comes in when you multiply your numerator times the conjugate. This would be the completed final answer, yes or no. You've got radical 21 and radical 21. Can we reduce those? If you take 21, isn't it 7 times 3? Aren't those primes? So it turns out that this is completely reduced as far as we can go. There's no like terms to combine, and they're reduced. So that's it for that problem. Now let's go on to a quick review. The radical expression cannot, absolutely not, stay in the denominator of the fraction. You have to multiply the radical denominator number, whatever it is, it's usually a term and a radical, by its conjugate. So again, if you have x plus 3, that means that the conjugate is x minus 3. And even if we stuck a radical in there, it still works the same way. All you're doing is writing the exact same terms, and the sign in between changes, and that's your conjugate. You're going to multiply the denominator by it, and you have to multiply the numerator by it as well. Right here, you have to multiply the numerator by the same conjugate because you have to keep them equal. Be sure to reduce any radicands that you can if possible. And the only way to double check these, there's no shortcut unfortunately, so you're going to have to go through and redo your multiplication and make sure that you added up all your exponents correctly and that you've fully reduced your radicands. And that's it for our lesson on radical expressions, rationalizing the denominator, a more advanced look.